This program has been produced to show the main maintenance procedures that should be carried out on the Leyland Lynx vehicle. Due to the wide variation in the vehicle operating conditions, maintenance on either a time or mileage basis may vary for individual operations. Carrying out maintenance and adjustments correctly contributes to vehicle safety and reduces the risk of vehicle failure in service. Before proceeding with the main part of this program, let's look at the general vehicle layout and specification. The Lynx chassis and body is of a fully integral design, consisting of a welded steel upper structure integrated with a rolling underframe. There is a Mark I and a Mark II Lynx. The Mark II, which has only recently been introduced, has a number of improved body and mechanical features and is easily recognizable from its predecessor by a restyled front grille assembly. All Lynx vehicles are powered by rear-mounted horizontal turbocharged engines, driving through a fully automatic gearbox to a hub reduction axle. The range of engines and gearboxes varies depending on the vehicle age and specification. For example, on early production vehicles, a Leyland TL11 or Gardner 6 HLXCT engine were used, driving through a fluid clutch to a 4-speed hydrocyclic gearbox. This latter unit was replaced by a 4- or 5-speed ZF automatic gearbox, depending upon engine power output. The Cummins L10 engine, at a later date, replaced the Leyland engine, with the Gardner still available as an alternative. With the introduction of the Mark II Lynx, the Cummins engine is still retained. However, the Volvo THD 102KF series engine, which is intercooled, replaces the Gardner. Because many of our existing training programs cover the maintenance aspects of the Leyland and Gardner engine adequately, we will in this program only be dealing with the Cummins and Volvo engines. To continue, the Lynx has a conventional beam-type axle. Direct air brakes are fitted with dual circuit to operate the front and rear brakes. Spring actuators on the rear provide a park brake facility. A taper leaf air suspension system is fitted to the Lynx on both front and rear axles. And finally, a fully integral power steering unit is fitted to give steering assistance. Before carrying out any work on the vehicle, always be aware of the basic safety precautions. Chock the road wheels. Ensure the handbrake is applied. Provide adequate ventilation when running the engine. Keep clear of rotating pulleys, drive belts and cooling fans. Always isolate the battery and display a warning notice in the cab when working on the vehicle. Finally, when jacking the vehicle, ensure that it is adequately supported using approved jacks and stands. Let's now look at the maintenance routines applicable to the Cummins L10 engine. In order to drain the engine oil completely, first ensure that the engine is at normal working temperature and remove these two drain plugs. This one drains the outer sump and this the inner. Most existing L10 engines have dual oil filters, a full flow and a bypass, located here on the side of the sump. However, on all current production engines, these two filters have been replaced with a single unit known as a combination filter. Providing the filter units have been installed correctly, they can normally be removed simply by unscrewing the assembly using a filter clamp. Before replacing the filter, always pre-charge it with clean engine oil to avoid undue lag in the oil supply system to the engine on initial startup. The filter sealing ring should always be lightly oiled before installation, as this will assist future removal. Screw the filter in until contact is made with the filter head. And finally, tighten the filter a further 3/4 to 1 full turn. To refill the engine with oil, add oil until the reading is shown midway on the dipstick marks. It should be noted that due to oil expansion as the engine reaches normal running temperature, the actual oil level increases towards the maximum mark. Therefore, if the engine is filled to the maximum mark when cold, the oil level will ultimately be above the recommended level, which can result in oil being thrown out through the breather pipe. Remember, therefore, always to check the oil level when the engine is at normal working temperature and immediately after shutdown. On the later engine ranges, an oil level sight glass is fitted to the sump as standard to supplement the dipstick. Moving now to the fuel filter maintenance, the fuel filter is located here. On the bottom of the filter, there is a facility to drain off any water that may be present in the filter. Simply unscrew like this, and when clear fuel is visible, re-tighten. But do not over-tighten, as damage may occur to the nylon threads. If it's necessary to replace the filter, it can again be unscrewed. To assist with fuel priming on engine startup, fill the filter with clean fuel prior to assembly, and again assemble the fuel filter until contact with the filter head is made, and tighten a further 3/4 to 1 full turn. When complete, start the engine, and any air remaining in the system should automatically purge after running the engine for a few minutes. If the system fails to prime, remove the fuel feed pipe to the fuel pump and pour clean fuel into the pipe whilst cranking the engine. To complete in this area, there is a small filter located in the fuel pump which is retained by this plug. Under normal circumstances, this filter only requires attention at overhaul periods unless the fuel system has been contaminated badly. On the L10, there is an engine breather located here, which can be dismantled for cleaning at each oil change period. The condition of this filter will depend on where the vehicle operates and also the general condition of the engine. Should the filter restrict the engine breathing, this will cause crankcase pressurization and create oil leakage from the engine oil seals and joints. The cooling system on the Cummins engine is protected against corrosion by a chemical additive, and a water filter collects any debris which may be present in the system. The additive, which is initially contained in the filter prior to dilution, is known as DCA4. The filters are available in different sizes, initially charged at different levels in units. Here are two examples. To avoid problems, the level of DCA4 should be between 1/2 to 2 units per gallon of water. To achieve this level, if, for example, the water system has been drained, the existing filter should be replaced with a 15-unit filter on the Mark I Lynx and a 23-unit filter on the Mark II, which has an increased water capacity. For normal servicing in both instances, providing the systems have not been diluted by topping up due to leaks or incorrect top-up procedures, a 6-unit filter should be fitted, as this is sufficient to maintain the level of additive and make up for deterioration in mixture strength. Remember, if the mixture strength drops below the recommended, the water system in total will suffer increased corrosion, and items such as the cylinder liner walls, which are in contact with the coolant, pit and corrode badly. Here is an example of this, where the pitting has penetrated the wall completely and allowed water into the cylinder. As an alternative, if the mixture strength is over-concentrated, it will attack aluminium components and solder, which are present in radiators and heat exchangers. Filter removal and replacement is identical to the procedures already discussed, with the exception that the water taps at each side of the filter should be isolated before the filter is removed. However, when the replacement filter is in position, do not forget to turn the taps back on. It should be noted that if the filter change period is neglected, the actual canister will corrode and will eventually cause coolant loss, with a risk of serious damage to the engine. In addition to the DCA4 additive, it is also recommended that the system is charged with antifreeze to a concentration of 50%. This not only gives adequate frost protection, but assists with corrosion protection. If the coolant has been accidentally diluted between services, a test kit is available to establish mixture strength, and the liquid DCA4 can be used to top the system up. To continue, our next check is on the fan motor. Ensure there are no hydraulic leaks and that the fan is free to rotate. Whilst in this area, remember the safety recommendations. The radiator shutter, if fitted, should be in the open position if there is no air in the vehicle auxiliary tank. If the system is in order, providing the engine is cold, the shutter should close when the engine is started and air pressure builds up. If the engine is run for approximately 5 minutes, you should be able to feel the temperature difference between the engine side of the thermostat and the radiator side. The engine side should be hot and the radiator side cold if the thermostat is functioning correctly. The next stage should be combined with a road test. After running for a short period, the shutter should open, thus confirming the thermostat on the engine has opened and the shutter is functioning. If the radiator matrix is now covered up, the hydraulic fan should cut in after a period of 4 to 5 minutes. During this test, always monitor the engine temperature light, and if this comes on, the test must be stopped immediately and investigated. It should be remembered that if the thermostat fails in the open position, the engine will run cold, causing high wear rates, dilution of the lubricating oil, and subject the engine to high thermal stresses due to the rapid fluctuation in operating temperature. Let's now move to the air cleaner system. Always ensure that the air trunking is intact and free from air leaks between the cleaner and the turbocharger. Be aware that the smallest of holes will allow dirt to be drawn in large quantities, causing damage to the turbocharger compressor wheel and increase wear rate on piston rings and liners, rendering the engine unserviceable at mileages as low as 10,000. The intake system has a depression indicator which indicates red if the air cleaner, due to dirt, is offering too high a resistance. This unit can be reset by pressing the button. Provided the air cleaner element is replaced at the specified mileages or at periods linked to suit the local conditions, this situation should never be reached. To carry out this work, remove the intake and exhaust trunking. Carefully inspect the condition of all blades on both the compressor and turbine wheels. If, for example, the air cleaner trunking has allowed dirt through, the compressor wheel will be heavily pitted. It should be noted that the compressor shaft will rock on its bearings. This should not be interpreted as a fault. In general terms, providing the assembly rotates freely without the turbine or compressor wheels fouling the casing when lightly loaded diagonally, this is a reasonable indication that the turbocharger is serviceable. Should any doubt exist, check the end float on the turbocharger. The clearance should not exceed 0.08 millimeters. To check the running clearance between the casing on the compressor and turbine wheels, lightly load the shaft diagonally and check the clearance on the opposite blade. The compressor blade clearance should be 0.2 to 0.47 millimeters, and on the turbine wheel 0.27 to 0.47 millimeters. During this section, we will be looking at the adjustment procedures for valves and injectors. On the L10 engine, there are 2 inlet and 2 exhaust valves per cylinder. These are actuated by rocker arms via crossheads. The long rocker arm is the exhaust and the short the inlet. The center rocker is for the injector. If you're required to remove the injector, first release the lock nut on the injector rocker arm and adjust the screw, and remove the main injector push rod. Then the injector link. Next, release the exhaust rocker push rod. With both arms free to rotate, you can now gain access to the injector clamp for removal. To remove the injector, a special extractor is available which locates on the injector like this. During the removal of the injector, take care not to drop the plunger or mix it with any other injector plunger, as each plunger is matched to each individual injector. Before refitting the injector to the engine, replace these 3 O-rings. If replacement injectors are to be fitted, always check the part number, located here, is suitable for the engine. Because there are many variations in spray pattern, spray holes, and fuel supply orifices to suit the various engine types and ratings. Make sure that the injector hole is clean before replacing the injector. Lubricate the seals and push the injector into place. It should, if located properly, snap into position like this. Replace the clamp and tighten the nuts evenly to a torque of 15 Newton meters. Failure to comply with this requirement may cause damage to the injector or jam the injector plunger, causing a misfire. Therefore, when the injector is in position, check that the plunger is free to move by using the push rod to lift the plunger. If in order, replace the push rod and link. To complete the injector replacement, the injector stroke must be set. We must set the engine in the correct position for each injector. Timing marks to do this are on the crankshaft pulley. In each instance, you have A, B, and C marks. Because the engine is a 4-stroke, we must use the A, B, and C marks twice if we wish to set all the injectors. A table outlining the engine positioning for injector setting is contained within the support notes. For example, if the C mark is aligned, we must establish which stroke the engine is on. If the valves on number 6 cylinder are closed, we can set the injector on number 2 cylinder. Or alternatively, if the valves on number 1 are closed, we can set number 5 injector. In this particular example, the valves are closed on number 6. Therefore, we can set the injector on number 2 cylinder. First, slacken the lock nut and tighten this screw using this special torque wrench, which is set to break at 0.6 Newton meters. Next, retighten the lock nut. To ensure that the adjuster screw does not turn, altering the initial setting, when the lock nut is tightened, a special tool is available which holds the central screw while the lock nut is tightened. This tool also provides a facility to use a torque wrench to ensure the correct torque of 50 Newton meters is applied to the lock nut. When the injectors are adjusted correctly during the injector stroke, the plunger just contacts the injector cup at the end of the injection. And to ensure that all the fuel is expelled from the injector, the camshaft is designed to load the injector plunger for a short period to squeeze out any fuel that may be remaining. This is known as cam nose crush. This feature avoids any possibility of fuel being left in the injector, which would result in a carbon buildup on the cup. You should be aware that if the injectors are not set correctly, it will affect the fueling of the engine. If the pushrod is slack, this will cause overfueling with black smoke, because the injector, when collecting fuel prior to injection, will be in the fueling position longer than normal and collect more fuel. This condition is known as set long, and in addition, the cam nose crush will not be effective, and the injector will carbon up over a period, resulting in a misfire and causing damage to the cup. As an alternative, if the pushrod is set tight, it will reduce the filling period of the injector, causing an under-fuel condition and reduced engine power. This condition is known as set short. In extreme cases, damage to the injector cup and camshaft may result because the crush imposed on the injector will be in excess of the designed limit. Therefore, care must be taken during the setting procedures. The next area to discuss is the valve clearance and crosshead adjustment. The A, B and C marks are again used to position the engine for the individual cylinders. And again, a table for guidance is contained within the notes. In this example, we're on the C mark, and we can therefore set the rockers on number 6 cylinder. First, release the inlet and exhaust rockers and remove the push rods. Next, release the crosshead lock nuts and the adjuster screw. Push the crosshead down, like this, and screw in the adjuster screw until contact is made with the valve head. And again, tighten the lock nut, taking care not to move the screw. Always position the adjuster away from the rockers on the crosshead. Otherwise, a foul condition will occur on the rocker arm. The valve rocker clearances should be set to 0.36 millimeters on the inlet and 0.69 millimeters on the exhaust. Again, the same torque spanner will ensure accurate setting and torque of the adjuster lock nut. To complete the Cummins engine maintenance section, let's look at the engine idling adjustment. Providing you have the necessary authorization and special equipment is available, the idling speed can be adjusted as required by first removing this plug on the fuel pump. If the special tool is then inserted into the fuel pump housing, clockwise movement will increase the idling speed and anti-clockwise will reduce it. The idling speed should be set to 600 RPM when correct. If for any reason the idling speed reaches 900 RPM, the gearbox control system will inhibit gear selection in D or R. It should be noted on conventional engines you would normally adjust this screw to alter the idling speed. But on the Cummins engine, this controls the throttle leakage fuel flow and must not be adjusted. Whilst in this area of the fuel pump, check that the fuel pump lever moves to the full throttle position correctly. If this is in order, it should knuckle like this. As contact is made with the maximum stop on the fuel pump. The lever, when the throttle is released, should contact the throttle leakage stop. You should be aware that a load sender unit is located in the linkage to control the ZF gearbox. Always ensure that the lever aligns with this mark at idle and this at full throttle. If this is not the case, the linkage must be adjusted. The stroke can be set by moving this ball joint in the elongated slot, and the stroke position by adjusting the rod length. This setting is very important because if the adjustment is badly out and a throttle condition is indicated to the gearbox control, selection of any gear will be inhibited. However, if the adjustment is only slightly out, it will, in one extreme, cause the gearbox clutches to slip during a gear shift, and in the other extreme, harsh gear shifts. Both these conditions are detrimental to the life of the gearbox. On the L10 engine, Poly V drive belts are used. Belt adjustment is carried out by movement of this idler. Slacken the idler lock nut and turn this screw clockwise to increase the tension. To avoid unnecessary belt wear, if the belt is slack, or alternatively if it's too tight, high bearing loads will be imposed on the alternator and idler bearings. The belt tension should be checked with this special gauge. The gauge should be located in this position on the belt. For reference, the belt tension should be set at 9 kilograms per groove. In this example, we have a 10 groove belt and should therefore be set at 90 kilograms on the gauge. If a new belt is installed, be aware that it stretches rapidly on initial running. Therefore, run the engine for 10 to 15 minutes and recheck the adjustment. Let's now move to the maintenance on the Volvo engine. This unit incorporates a dry sump system, which means that the oil for the engine is contained in this external tank. During normal running, oil is drawn from this supply to feed the engine, and a scavenge pump within the engine returns the oil back to the tank after lubricating the engine. To carry out a complete oil change, there are 3 drain plugs, one here on the main oil tank and 2 on the engine, on the oil pan and this inspection panel. The engine has 2 screw-on filters mounted on the near side of the engine. The small filter is the full flow and the larger unit the bypass. During replacement, pre-charge the filters with engine oil to avoid undue starvation to the engine lubrication system on initial startup. Before replacing the filter, lightly lubricate the seal. Then, tighten by hand till contact is made with the filter head. And rotate a further half to 3/4 of a turn. When refilling the engine, add oil to the external tank until the level indicator on the sight glass is between the minimum and maximum mark. Start the engine and allow to idle. During this period, always ensure that the oil pressure light goes out without any undue delay. And finally, check the oil level in the oil tank with the engine still running and top up as required. To continue, the 102 engine has 2 engine-mounted fuel filters which can be unscrewed if replacement is required. If you wish to check that the existing filter elements are serviceable, install a pressure gauge between the filter outlet and the fuel injection pump supply. When complete, run the engine at full throttle and then allow the revs to drop down to idle. Read off the fuel pressure reading on the gauge within 1 minute. The pressure reading must not be less than 100 kPa. Should it be below this figure, the filters must be changed, as they're starting to show restriction and will affect engine power output. When replacements are fitted, recheck the pressure. If it is still low, a further check will have to be made on the lift pump and fuel injection pump pressure relief valve. Whilst in the fuel pump area, check the engine idling speed, which should be 550 to 600 RPM. If adjustment is necessary, this can be achieved with this adjuster. To complete the operation, select D and check the engine RPM with the vehicle in gear. The revs should not drop below 500 RPM. With the engine stationary, operate the throttle pedal fully and make sure that the fuel injection pump lever is in firm contact with the maximum speed stop. Remember, if any adjustments are made to the throttle linkage, be sure that the ZF gearbox load sender is readjusted correctly. Always ensure that all tamper-proof seals are intact. Our next check is on the condition of the pump drive shaft coupling drive plates, and ensure that the clamp bolt at the front of the coupling is tightened to a torque of 16 Newton meters. If the coupling shows any sign of movement, the fuel pump timing must be checked. To do this, first operate the manual stop control. By removing this cover, access can be gained to the flywheel timing marks. On this engine, the flywheel should be set to 14 degrees before top dead center. However, to ensure that the engine is on the correct stroke, rotate the engine until this reference mark on the fuel injection pump coupling is approaching this pointer. And then line up the 14-degree mark on the flywheel. If the scribe lines are in line on the coupling, the setting is correct. Should any doubt exist as to the accuracy of the marks, the following procedure should be used to check the timing. Remove this banjo bolt and plug, and fit this bracket, dial gauge and extension probe, so that it's in contact with the pump cam follower. Release the pump coupling, rotate the shaft backwards until the pump camshaft is at bottom dead center, and then zero the dial gauge. At this stage, we must refer to the Volvo diesel test standards for the plunger lift details for this engine. In this instance, the figure is 3 to 3.1 millimeters. Rotate the coupling in normal direction until the dial indicator gives a reading specified in the test standards. And then finally, retighten the drive shaft clamp bolt to the specified torque. This setting should be checked. However, remember to rotate the engine backwards at least a quarter turn before bringing it back to the 14-degree mark on the flywheel. The condition of the air cleaner element must be checked by inspecting the pressure drop indicator located on the intake trunking. If the indicator shows red, like this, the air cleaner element must be changed. On completion, reset the indicator by pressing the reset button. Inspecting the air trunking is important, as any air leaks or holes let unfiltered air into the engine. In extreme cases, dirt ingress will pit the turbocharger compressor blades and cause rapid wear on cylinder liners, rings and pistons, and give results similar to this. If the intake housing is removed, the compressor wheel can be inspected for damage. In order to check the turbocharger operation, push the shaft inwards and at the same time rotate the blades. The assembly should rotate freely without contacting the casing. The same procedure should be carried out with the shaft in the opposite direction. If the shaft is loaded diagonally, the assembly will rock in its bearings, like this. This is not a fault, provided the compressor wheel is still cleared of the casing. If you wish to check the turbocharger performance, this can be done by installing a test gauge on this connection on the inlet manifold. Because the test has to be conducted on the road, the gauge will have to be visible in the driving compartment. The vehicle should be driven on a suitable gradient, whereby full engine load and throttle can be achieved. When the engine speed passes through 2,200 RPM, the pressure reading should be recorded. This test should be repeated a number of times and then take the average reading. For guidance, the reading should be in the order of 1.3 bar if the turbocharger is performing correctly. It should be noted that if the engine passes through the 2,200 RPM band too quickly, there will not be sufficient time for the turbocharger pressure to stabilize. Therefore, you will have to select a slightly steeper test gradient to achieve the correct reading, or alternatively, partially apply the brakes. If the reading is low, check for air leaks on the inlet manifold joints, the boost control pipe, and finally ensure that the fuel pump is receiving full throttle, as underfueling will also give low boost pressure readings. In order to set or check the valve clearances, the engine must be cold, and as a safety precaution, pull out the manual stop control. To set the valves on number 1 cylinder, rotate the engine till the valves on number 6 cylinder are on the rock. This procedure can be used for each of the cylinders outlined in this table. The valve clearances should be set to 0.40 millimeters on the inlet and 0.70 millimeters on the exhaust. However, be aware that the inlet and exhaust valve layout is different in many engines due to the individual cylinder head configuration. The exhaust valve is always on the right and the inlet on the left. The 102 engine has 2 cooling systems, one for the main engine cooling and a second circuit to provide cooling to the air entering the engine. This is known as intercooling. On the front of the engine is a gear-driven water pump, which has 2 separate pumping elements. This one provides engine cooling, the outer for intercooling. The main engine thermostat is set to operate at 82 degrees centigrade. A separate thermostat for the saloon heating is also located in the same housing, set to open at 60 degrees centigrade. On the intercooler circuit, a 20 degrees centigrade thermostat is mounted in this water pipeline to control water flow to a separate radiator mounted in front of the main radiator. The hydraulic fan switching arrangement is identical to that explained earlier in this program. However, with regard to the radiator shutter, this is not fitted with the Volvo engine, as this would affect the intercooler radiator performance. With the cooling system, it's important to check the antifreeze concentration, which should be between 40 and 60%, which gives adequate frost protection and, in addition, provides protection against corrosion within the water system. With regard to the latter, this level of concentration must be maintained all the year round to protect the engine against corrosion. It should be noted that if the antifreeze mixture becomes diluted, the water becomes extremely acid, particularly at concentrations of 15 to 20%, even more so than ordinary water. Therefore, failure to observe this recommendation will result in corrosion within the cooling system components and radiator blockage. To complete the cooling system inspection, check the condition of all water hoses and replace any which show signs of hardness or damage. If the system requires to be topped up regularly, a pressure test should be carried out to identify the leakage point. In order to carry out an oil and filter change, the transmission should be at normal working temperature. The drain plug is located here. To gain access to the filter, remove this cover plate and withdraw the filter element. Next, remove the suction tube. Replace this O-ring and lubricate with oil, and then push the suction tube back firmly into position. Ensure that the O-ring in the replacement filter is in position. Replace the filter and push into position. Replace the O-ring in the end cover and again lubricate with oil. Replace the end cover and ensure that the bolts are tightened with a torque wrench to avoid damage to the gearbox. To refill the gearbox with oil, initially add 2.6 gallons. Start the engine and add a further 1.1 gallons, pouring slowly. The oil level, if correct, should be between these two marks. To complete the refill procedure, bring the gearbox to the normal working temperature, to approximately 80 degrees centigrade. With the engine at idle, if the oil level is correct, it should be between these two marks. This final procedure is known as a hot check and is the only accurate method to establish the precise oil level and should therefore be used at all times. It should be noted that if the filter change period is neglected, because it's on the suction side of the oil pump, the gearbox will progressively lose drive due to clutch slip as the filter restricts, causing major damage to the gearbox. On the Mark I Lynx, the gearbox is fitted with an AM6 control system. And from a maintenance point of view, the only check is to ensure that the load sender is set correctly, as seen earlier in this program. The Mark II range has a more advanced control known as EST18. With this system, if the control panel detects transmission slip in drive or during gear changes, or a speed signal fault from the turbine sensor, the driver's selector switch lights will flash. With this system, if the control panel detects transmission slip in drive or during gear changes, or a speed signal fault from the turbine sensor, the driver's selector switch lights will flash. In this condition, the vehicle must be rectified before returning to service. The control system is designed to record up to 55 different faults and store them in the panel's memory, and also the number of times that fault has occurred. To extract this information from the panel, this test kit, known as the Moby Dick 200, is plugged into this lead. And by operating the fault diagnosis program, a fault code will be displayed here, and the number of times the fault has occurred. By cross-reference to the manual, the fault area can be identified so that action can be taken to rectify the fault. On the EST18 system, there are two gear engagement interlocks, which must be checked. For example, when D is selected, the gear should not engage unless the handbrake is applied. And with reverse gear, this should not engage unless the handbrake is applied and this separate reverse switch is operated. Any malfunction on these interlocks must be corrected for safety reasons. The rear axle on the Lynx is a hub reduction design. Before proceeding with the maintenance procedures, let's look briefly at the hub structure. From this diagram, the layout of the hubs and planetary gears can be seen. This is the planetary gear consisting of the sun wheel on the axle shaft, planet gears and annulus. The annulus is held stationary by a fixed gear, which is splined to the main axle tube. The hub has two oil seals, the main seal and an O-ring. Should either seal leak, oil collects in this chamber and drains out through holes in the annulus casing. The hub bearing end float is controlled by this sleeve and a series of shim washers, and axle shaft end float by this thrust screw in the annulus end cover. The rear axle can be drained here from the main casing and refilled through this combined filler and level plug. Because the rear axle has planetary gears in the hub, they're lubricated with gear oil. To drain the hubs, remove this plug and rotate till the plug is at 6 o'clock. To refill, set the filler in a horizontal position as indicated and top up. It's important to check that the axle breather is cleaned periodically, otherwise if it becomes blocked, pressurization within the axle will result, causing oil leakage at seals and joints. Let's now move to the rear hub removal and replacement. If basic jacking equipment is used, the jack should be positioned under the spring clamp plate. And for safety, a wooden block placed under the taper leaf spring to the rear of the axle, this being the thickest part of the spring link. If metal stands are used, make provision to avoid scratching the taper leaf spring, and be aware that you should not at any time jack or block under the taper leaf spring at the front of the axle where the leaf is much thinner. To continue, in order to remove the hub, it will be necessary to remove the brake drum. To do this, first release the park brake, providing there is air pressure available, and then wind off the spring brake mechanism. This can be achieved by removing this cover and inserting a socket spanner rotated in an anti-clockwise direction. To continue, first remove the brake drum securing screws. And if required, use 2 of the retaining bolts to extract the brake drum. Next, remove the annulus end cover and withdraw the axle shaft. Remove the annulus retainer screws and again use extractor screws to remove the casing. As the annulus casing is heavy, it may require assistance during removal. Release the lock tab and undo the hub retaining nut using a special spanner. Remove the annulus gear, bearing, shim washers, bearing spacer, and finally the hub. The seal can be removed from the axle casing using a pry bar. On initial assembly, it is necessary to assemble the hub without the seal in position to establish the end float. The reason for this is that the seal offers so much resistance that the end float cannot be felt if it's installed first. Therefore, this procedure must be adopted to establish the end float prior to fitting the seal. The hub nut has to be tightened to a torque of 1,870 Newton meters. To do this, tighten the nut lightly with a spanner and mark the edge of the nut. Tighten the nut a further 1 slot, and this will have tightened the nut to the equivalent of 1,870 Newton meters. The hub end float, if correct, should be between 0.12 and 0.2 millimeters. If this is not the case, the shims must be changed in the hub. The oil seal is known as a unitized seal and is marked for correct fitting. Sealant should be used on the axle beam to seal the inner surface of the oil seal. The oil seal should be driven into position using a special drift. When correct, the inner surface should be flush with this surface on the axle beam. The next stage is to reassemble the hub, engaging the hub onto the seal. The hub nut should again be tightened, again using the same technique as used before, to ensure the correct torque. Next, fit the O-ring to seal the casing to the hub. Remove the annulus from the annulus casing and install onto the annulus fixed ring, as this is the easiest method of refitting. Fit the annulus casing. It'll be necessary to tap the casing over the O-ring. Refit the screws. To ensure easy engagement of the axle shaft, remove the sun gear on the shaft and enter the shaft into the diff separately. And then reinstall the sun gear onto the shaft. Then engage the planet gears, and finally refit the circlip. When refitting the end cover, use Loctite sealant on the securing screws to avoid leakage. To adjust the axle shaft end float, release the lock nut, turn the screw in until contact is made with the end of the axle shaft, and release 1/3 to half a turn. Retighten the lock nut, and finally top up the hub with oil as before. If you're required to remove the front hubs, the vehicle can be jacked up on the suspension beam in line with the taper leaf spring and blocked here. The front hub is of conventional design, and hub end float is controlled by adjustment of the adjuster nut. There is a spring-loaded spacer between the bearings, the function of which is to restrain the inner cones on the bearings from rotating on the stub axle. When replenishing the hub with grease, only load the grease to a depth of 2 millimeters. Here is an example. The end float of the front hub bearings should be between 0.08 and 0.2 millimeters, and if you wish to adjust or replace the hub, follow this procedure. Assemble the lock ring and the clamp nut, and tighten the nut fully, and rotate the hub. This will ensure that the bearings are located correctly. Next, release the hub nut until the required clearance is obtained. At this stage, ensure that the locking screw will enter the lock ring. If not, reverse the locking plate, which will move the hole around by half a hole. Refit the hub nut and adjust the end float once more. You will now find the locking screw will align with the hole in the lock plate. After tightening the clamp bolt, recheck the clearance, as the clamping action on the stub axle threads may have moved the clamp nearer the bearings, thus reducing the bearing clearance. If so, the initial clearance will have to be set wider to allow for this take-up. It should be noted that operating the vehicle with insufficient clearance or a preload on the bearings will reduce the bearing life considerably.